Hello and welcome to our video on distance formula. And for the distance formula, I would like to, I know a lot of people get scared away by the distance formula just because it's a big, long, nasty formula, but what I want to tell you guys is that for distance formula, basically what you're trying to do for the distance, you're just trying to find the length of a line. And so when we're talking distance formula, that's just a way to find the length of a line. So anytime you hear distance formula, we're just meaning what is the length of the line. There are two ways of going about it. One way is the distance formula, which is what we see here in part A, and so it's this, and it usually is helpful if you have ordered pairs. The other way is to use Pythagorean theorem. And so in my example that I'm going to give in this video, I'm going to use the distance formula and I'm going to use Pythagorean theorem as an option to finding the length of the line. So you'll see with both ways I should get the same distance or same length of a line. It's just a matter of which one do you prefer, and so you can use either of them. Both of them will work. So I have this example here that I'm going to find the length of the line. So my option number one is to use the distance formula, and you'll notice that on it I have put the ordered pairs that make up the endpoints of the line. Well, those guys correspond with the x's and y's in my distance formula, so it doesn't really matter which one I choose for x1 and which one I choose for x2 or y1 or y2. The only thing is, if I pick one for x2, then I need to have the y2 match up with it, and so on and so forth, just like we kind of do with slope formula. So if I'm going to go ahead and find the distance formula, I'm going to set it up just the way it looks right up there, and I'm going to pick this top one to be my x2 and y2, and then this one down here will be my x1, y1. So it says subtract x2 from x1, and so I'm going to say 4 take away -2, and remember I'm subtracting a negative so it becomes positive, and then I am going to subtract my y values, 9 take away 1, and square it. And so now at this point the hard part of it has been done. It's just a matter of simplifying it. And so when I go ahead and simplify this formula, I'm just going to simplify what's underneath the square roots. 4 plus 2 is 6, so I really have 6 squared. And 9 minus 1 is 8, so I'm squaring 8. And then I haven't done anything with the square root yet. I'm just simplifying underneath the square root. 6 squared is 36. 8 squared, 64. And then continuing down, if I combine 64 and 36, I believe I get 100. And when I take the square root of 100, the length of the line is 10. And that's just using the distance formula. I plugged in my x values and subtracted them, plugged in my y values and subtracted them, and then squared them and worked my way down. Well, you may be asking yourself, well, how does this relate to the Pythagorean theorem? Well, with the Pythagorean theorem, I can go ahead and draw a Pythagorean theorem. Remember, deals with right triangles. So what I'm going to do is I'm going to draw a right triangle out of making the line that I'm trying to find the length of the hypotenuse of the right triangle. So I have this right triangle that I just drew in here. And what I need to do is, if you remember with Pythagorean theorem, A is one of the legs, B is the other leg, and C is the hypotenuse in our Pythagorean theorem. So if I could find the length of A and then the length of B, I can work through Pythagorean theorem to find the hypotenuse. So what is the length of A? Well, it's just a matter of counting. 1, 2, 3, 4, 5, 6. So A is 6, so I can say that's 6 squared. B, if I count B, should be 8 squared. And C is the distance that I'm trying to find, the length of the line. And so that's the side I'm looking for. So I have to work to find that. Now you may notice that there's some parallels between the Pythagorean theorem and the distance formula. If you look at the distance formula at this second line that I wrote up here, it looks kind of familiar to what I've got down here. If I go ahead and square 6, well, that's still 36. And if I square 8, that is 64. And again, you may see that these are parallel to each other, that I'm getting the same thing. There's my 6 squared and my 8 squared. There's my 36 and 64. If I combine these guys together, I get 100. And the only difference is, in the distance formula, it says d equals square root of 100. Well, down here for Pythagorean theorem, I have c squared equals 100. Well, you have to remember how to solve an algebraic problem with a square in it, and in order to get rid of the square, we do the opposite operation, which is square rooting, and so I get a square root both sides, and when I square root both sides, the square on the c goes away, and the square root of 100 is 10, so you'll notice that the distance, and when I do Pythagorean theorem, will get me the same answer. So what I want you guys to understand is I don't necessarily need you to understand the distance formula unless you like that one. Pythagorean theorem works just as well, but we're going to go back and forth between the two, and sometimes the distance formula is a better option, because the distance formula, the option of the distance formula, you don't have to draw out the triangle, and sometimes it's not to your advantage to actually draw out the triangle. Sometimes it's best just to plug in the ordered pairs and simplify. So when we're doing this, make sure that when you kind of figure out both ways, but you can always draw out the triangle if you want to, or you can always use the distance formula, but both of them will get you the same answer. If you have questions on these, please come to class with your questions, and we will talk about them and hopefully answer them, and we'll bring up some more questions as we go.